Hello.
Good afternoon.
I'm gonna wait a few minutes to see who else is logged in. So I see Jeremy. I'll be pronouncing your name right, I hope. Who else is on here? Isabella. Isabella Ferreira, can you hear me?
The only Isabella here I think is me, and my last name's not Ferrera though.
Rivera.
Oh yeah, Rivera.
Okay. How you doing?
Good.
Good. I'm just taking attendance and making sure that y'all
All right.
are on. I'm Miss Michelle. I don't know if we ever met before, but I'm Miss Michelle.
Oh yeah. You did practical for a while, I think, right?
Oh, yes, I did. Okay. Good memory. I'm looking for you on my roll sheet. Oh, I see.
Gabby's popping on in a minute.
Okay. Oh, wow. Let's see. Jacqueline Campbell. Charlene. Marina. Good afternoon, ladies. Good afternoon, ladies.
Good afternoon.
All right.
Hi.
That's what I'm talking about.
Oh, I can't see you.
You can't see me? How about now?
Beautiful.
Yeah. So, Jennifer. Okay. I'm still doing roll call. Yeah. Oh, Mackenzie. Okay. Hi, Jennifer. I'm Mackenzie. I'm Mackenzie. Okay. Just give me a few more minutes. You know, I'm doing roll call. People popping in. 2 o'clock. About 5 more minutes and then I'll get started. But today we're going to review back chapter 5, chemistry. Okay. So about 5 more minutes. Let's see. Gabriella. Hi, Gabriella. Let me know if I'm pronouncing y'all names wrong. I'm doing the best I can. Gabriella. Can you hear me? Hello? Okay, no, she's unmuted. Two, 4, 6. Hi, Natalie. Okay, so I'm going to get started. Can you ladies hear me well? Because a lot of students are not responding.
Yeah.
Okay, great. So far I have Natalie. Can you say hi or show me a thumbs up? Natalie Lopez. Natalie Lopez. I can't see you or hear you. Mackenzie Rice.
Here.
All right, that's all I need to hear.
Charlene, hey.
I think some people logging in and then walking away from this screen. Lorena Costello.
Here.
Thank you. I said hi to Jeremy, Jennifer, Jacqueline,
Oh, so you skipped me. Okay.
Gabriella. Okay. All right. So we're doing a review. So last week we talked about the pH scale. What does the pH stand for? Potential hydrogen. It measures whether substance is acidic or neutral or alkaline. Okay. And I have an example of the colors of the pH scale. Can everybody see that? Okay. Oops. Hi, Brianna. Okay. So I'm going to do some testing today in a few minutes with the strips. Okay. So we have the water-based solutions on the pH scale. Okay. The water-based solutions. pH measures amount of acid or alkaline in a water-based solution only. Acid is more positive hydrogen ions than negative hydroxide ions. And the neutral, which is the 7 right in the middle on the pH scale, is equal number of hydrogen and hydroxide ions. Alkaline is more negative hydroxide ions. Okay. Acid on the scale from 0 to 6.9. 0 to 6.9 is more positive hydrogen ions. Okay. And it's skin and hair acid balance at 4.5 to 5.5. So skin and hair is usually ranges from 4.5 to 5.5. Okay. Then on the alkaline side, which is the side on the right, alkaline, is more negative hydroxide ions. Okay. And it's usually ranges from 7.0 to 14 on the pH scale. Okay. So what is the pH scale? It's a unit of measurement. Determines if substance is acid or neutral or alkaline ranges. Okay. Testing pH and natarazine paper. Okay, these little strips like this. Okay, is your testing strips. You can also test it with a pH pencil or a pH meter. Okay, so I'm gonna do a little testing just so we can see where it's at. So this is regular shampoo, and we're gonna get into the different shampoos. Okay, so if I dip it in the shampoo, see there? I even label my cups. Let's see. Then you wait to see what color that's coming up. So if I look on the pH chart, let's put it here where everybody can see it. Hold on 1 second. Okay. Can everybody see this? Okay, it's about a 6. See how it's turned green? And look on the chart. It's about a 6. So is it acidic or alkaline? Don't everybody answer at once. Somebody take a guess.
Acidic.
Very good. It is acidic. Right? Okay. So now I have bleach, Clorox bleach. Let's dip that. Whoa, what color is that? Look at this. I'll say it's a 14. Can everybody see that? Between a 13 and a 14. See how dark it is? If I hold it up here. Yep. Okay, so that was Clorox bleach. Okay. Now I have the disinfectant solution, okay, that we use to disinfect our tools and implements with. Put that in there. I think that's about a 13. That's almost as dark as the Clorox. Okay, now with this one, you dilute it with water, of course. Okay, I got it straight out the bottle. Okay, so just so you can see how strong it is until you dilute it. Okay, so that's the disinfectant solution. Okay, now I have ammonia. Yep, that's kind of high too. This is ammonia. 13 and 14. Okay. All right. What else I have here? Okay. Vinegar. This is white distilled vinegar. That's about a 2. Yep. So that's on the acidic side. Sorry. Astringent, like your witch hazel and your sea breeze, astringent. Look at that. That's almost the same color as the paper. No, it's not. It's a number 3. It's number 3. I thought it was more yellow, but that's a number 3. So that's still on the acidic sign.
Now, our papers that we're using, the litmus ones, how they're yellow, is that
Mhm.
what they test all of these with? Is that same yellow color? Or is ours maybe being a little distorted, or do they use a white one ever?
That's a good question. I don't know the answer to that, but we could find out. Okay, this is what the school provided us, but that's a good question. And I see your point. Is it changing it? I don't think so, because look at, I don't think the yellow has anything to do with it. That's my personal opinion now. Because look, you could still see the color, right? See how it's still changing? Okay. Even down to the shampoo. That's in the 6th rank. Nope. Turn it on this side. It's more like a 5 because it has some green in it. Okay. Some shampoos, most of the shampoos is on the 6. Okay, but are you using a dandruff shampoo? Are you using a medicated shampoo? Okay, this one is a hydrating shampoo, so it has a little moisture in it. Okay, so I think that's why it's a 5, it's not so strong. And last but not least, I'm gonna find out the answer to that question, Jennifer, and I'm gonna get back with you, okay? Lemon juice. Right there, number 2. Okay, and then this is a copy of a piece of paper too. So even though it's in the same category, it's a little richer. You see what I'm saying? The printout is a little deeper than these swatches, but you could clearly see that this is a number 2 compared to these blues and how dark. Look how dark this came out. Okay, that was the bleaches and the ammonias. Okay, did anybody get to do them at home? No. That would have been fun if the students would have got to do it at home and share their experiences with it.
Yeah, they sent us home with litmus paper and asked us to do 5 samples last week. And we
I know, and I had nobody show me any.
Really? I sent mine in.
Oh, you did? Oh, okay. Probably not in class, but yeah, I forgot about
No, I did them on the zip whip thingy.
Right, and then sent it in. Yeah, I forget about that. I'm still back to the old school when you show the teacher in class. I forgot you doing everything on the computer now. Okay. So how did you feel about that? Did you feel that if it was white, it would have been better?
Well, I don't know. I wondered because like I used red wine as one of them, and it came out really super acidic. But I was wondering, I'm like, is it really that high in acid? Like, why would they sell that for us to drink? if it
I
was
think
that high, I wondered if maybe the yellow color of the paper was making it appear
Oh,
orangier.
I see, but look at the lemon juice. We drink that. And lemons and the natural stuff that's acidic and the oranges
Yeah.
and the tomatoes, you know, but that's not the acidic that's, you know, like straight up acid that's gonna, you know what I mean?
Yeah,
But some of us, I know me, especially if I drink wine, I'm not telling all my business, but it gives me heartburn and some people drink it, don't have no problem. So, you know, just like any other person that's on a special diet or eating habits, one thing might affect you different than the other. Okay, so no, I don't think they definitely, with all these wine lovers out here, is not gonna. Okay, but good questions. I love it. Okay, so matter. Anything that occupies space and exists in three forms: solids, liquids, and gases. Nails, skin, hair, and water, even oxygen is matter. Okay, so the example of a solid matter is hair. An example of a liquid matter is perm solutions and shampoos. An example of gases is oxygen. No, not the gasoline that we put in our cars. Some student had asked that. It's usually the gases that you can't see. You could smell them, but you can't see them. Okay. So we have organic matter that is now living or alive at one time. Example, plants and animals. Inorganic matter that is not alive or has never been alive does not contain carbon, like example, rocks, water, and minerals. Changes in matter, you have a physical and a chemical change. Okay, in the physical change, the characteristics without making a new substance. Okay, so in other words, it's physical like the ice that changed into, when it melts, it turns into water. It's the same substance. It's just that when it's frozen, it's solid, and when it melts, it's liquid. So a chemical change is a substance that creates a new substance with a chemical characteristics different from those of the original substance. So that's when you mix one substance inside another. And the perfect example is your color. When you mix your color with your developer, it changes it, even though you have two different substances. But when you mix it together, it becomes something totally different. Unlike the physical phase where you got the frozen ice that's going to change into liquid. It's the same substance. Okay. Properties: color, odor, weight, as far as density in the hair, when they say weight, and 4 is the hardness or the softness, as in water. Water could be hard or it can be soft. If you have a filter on it, it will soften the hard water up. Okay, elements. All matter is made up of elements. So your basic substances that cannot be broken down into smaller substances, all matter is composed of atoms, which make up elements. Okay, so we even have abbreviation COHN. What does that stand for? C is for carbon. O is for oxygen, H is for hydrogen, and N is for nitrogen. And S is for sulfur. Like that one. Remember, Cohen's is elements that make up hair. So carbon, oxygen, nitrogen, hydrogen, and sulfur make up hair. Atoms are the smallest complete unit of an element. There are 3 parts of an atom. You have a proton, which is a positive electrical charge. It gives the atom its name. You have a neutron, no electrical charge. It determines the weight of an atom and it's neutral. An electron is a negative electric charge, makes it possible for atoms to combine with other atoms to form bonds. Molecule. Two or more atoms joined together by a chemical bond. Unstable atoms combine chemically by sharing electrons. Okay. Can somebody give me an example of a solid matter? That look around you and within your space. I know you have an example of a solid matter. Okay, your car is a solid matter. A desk is a solid matter. A shelf is a solid matter. Okay. Floor, your floor that you're standing on, that's solid. Okay. What is liquid? Give me an example of a liquid.
Water.
Yes. You have water. Okay. That's an example of liquid. Or this lemon juice and even the shampoo, that could be liquid, right? What is the example of a gas? Oh, don't be funny. Okay, what are we doing now? Our chest is rising and falling. So what is that? When your chest, I don't want to say the word. Breathe the air we breathe. Okay, that's an example of a gas. Okay. So what is a change in substance characteristics without making a new substance? That's a question.
You said a change without making a new substance?
Physical change, correct. What is a negative electrical charge? Negative electrical charge. The word is kind of in the answer. Electron. That's a negative electrical charge. What's a change in a substance that creates a new substance and a new characteristic?
Chemical.
Chemical change, very good. And anything that occupies space, what is that?
Matter.
Anything. Yep, matter. And what's the smallest complete unit of an element? The smallest complete unit of an element. An atom. Very good. Okay, now I'm going to talk about the bonds. So the chemical bond is atoms combine chemically to create compounds that eventually create protein of hair. Once again, a chemical bonds are atoms combine chemically to create compounds that eventually create protein of hair. Amino acids, those are compounds of COHN, which stands for what? We just went over that.
Carbon,
CL,
oxygen, hydrogen, and nitrogen.
Exactly. There are 22 common amino acids joined together in chains to make proteins. Protein. What is protein? Its hair is made up of protein called keratin. And I know we see those when we're shopping for shampoos and conditioners. You see the keratin and the protein labeled on the bottles. Hair is made up of protein called keratin. Hair is 97% keratin and 3% trace minerals. Hair contains 19 of the 22 common amino acids. Okay, next is hydrogen bond. The hydrogen atom in one molecule is attracted to an atom of another molecule that has many negative electrons. Hair has many hydrogen bonds, which are individually very weak and can easily be broken by heat or water. About 35% of the hair strength is due to the millions of hydrogen bonds in its structure. Okay. So once again, about 35% of the hair strength is due to the millions of hydrogen bonds in its structure. Salt bond. This bond is a result of the attraction of unlike charges. The negative charge in one amino acid grouping attracts the positive charge in another amino acid grouping. So the salt bond is a result of the attraction of unlike charges. The negative charge in one amino acid grouping attracts the positive charge in another amino acid grouping. The sulfide bonds, a chemical bond that forms between protein structures, sulfur type side chains, joined with other sulfur type side chains. They form the disulfide bond. So what is a disulfide bond? A chemical bond that forms between protein structures, sulfur type side chains, joined with other sulfur type side chains. They form the disulfide bond. Van der Waals forces is atomic groups prefer an environment with other groups that have structures similar to theirs. So what is Van der Waals forces? It is atomic groups prefer an environment with other groups that have structures similar to theirs.
Would we likely be asked about this at state board since it really doesn't have a whole lot to do with hair and what we do?
Well, it does, because what they're trying to do is to tell you with matter, you know, and then they give you example of hair and shampoos, you know, with the liquid. So it's trying to tie, it is tying a little bit of chemistry. Of course, it's not like a chemistry course if you was going to, you know, the the college, but so we trying to correlate the main things about chemistry, you know, that's relating to what we doing in cosmetology. Does it make sense? Okay, so like at the beginning, it's talked about matter, and it says anything that occupies space, and it exists in three forms, but it says nail, skin, hair, and water. Even oxygen is matter. So see how they correlate in hair, skin, because what are we doing? We're gonna be doing hair, we're gonna be doing nails, and we're gonna be doing skin, right? So they trying to just, if you notice in the chapter, it starts repeating itself and it just goes over a few things that we're going over. It's not getting into the technical because we're not trying to become scientists, but we are trying to become mixologists and hair designers. Does that make sense? Okay, so, right, okay. So they're just specifically talking about what we relate to hair, skin, and nails, okay? What was that? Here we go. Protein. See, well, here we go. They break it down. Protein, hair is made up of protein called keratin. Hair is 97% keratin and 3% minerals. I think I said that already. And then the hair contains 19 of the 22 amino acids. 19, that's a lot out of 22. Okay. Yeah. N bonds. Backbone of all protein molecules. Link the amino acid protein chains together. Peptide bonds. Okay, so N bonds is also known as peptide bonds. Okay, so give your example in your book of how, I don't know if you can see, the amino acids and how they link together. Oh, let me move it back some, see there? Okay. So they say the hydrogen is up here, the disulfide and the salt, and the van der Waals. And right, when you look on the paper, it look like this change, but they trying to tell you, well, this is where the side bonds are, okay? And how they all link together. End to end, do not disturb the N bond. So the N bonds are the backbone of all the protein molecules. They link the amino acid protein chains together end to end and do not disturb the N bond. Then you have the side bonds that I just mentioned. They link the long spiraling protein chains together, hydrogen, salt, disulfide, and van der Waals forces. Those side bonds link all the other bonds together. Okay, so once again, the N bond should not be broken. If broken, it will revert back to amino acid groups. And the side bond is hydrogen bond can be broken to form physical change. Salt bond can also be broken to form a physical change. And the sulfide bond, when broken, causes lasting chemical change. All right. So now we are going over the chemistry of cosmetics, and you have a few homework questions that talk about that. Like, what are the different types of shampoos? Okay. And there's about 1, 2, 3, 4, 5, 6, 12 of them. Okay. But before I get to that, I want to talk about the cosmetic classifications. Okay. So based on how well substance combines and physical characteristics. Okay. So solutions, the mixture of 2 or more kinds of molecules that do not separate can Oh, why didn't I see that? I'm just been talking. Okay, we're talking about chemistry of cosmetics. So solutions, a mixture of 2 or more kinds of molecules that do not separate, such as oil and vinegar. You see how when you put those 2 together, they do separate. I'm sorry. When you mix your peroxide and your color together, that doesn't separate once you mix that together. But you notice that when you put all of it together, how it does separate, you have to keep shaking it. Okay, so that's the opposite of the solution. Suspension is mixture of 2 or more kinds of molecules that separates, needs to be shaken. Okay, that's the suspension. Okay, a solution is 2 different molecules that mix together. They do not separate. And the suspension is the example of the vinegar oil, how it does separate. So if you get a cup of vinegar and you put oil in it, you're going to see the oil kind of mix circles and it doesn't mix well until you shake it. Does everybody got that? Okay, so that would be an example of suspension. Okay, emulsions, 2 or more non-mixable substances united by a binder. Gum, oil, and water. Perms, water, and oil. Cold cream. They're giving you an example of emulsions. Ointments are a mixture of organic substances and a medicinal agent, semi-solid form, no water. Lipstick. Soaps. Are mixtures of fat and oil converted to fatty acids by heat and then purified. Powders. Equal mixtures of inorganic and organic substances that do not dissolve in water. They are sifted and mixed until free of coarse grit. Shampoos. They clean the scalp and hair, remove all foreign debris without adversely affecting the scalp or hair. How it works. How does shampoo work? It's a push and pull action caused by a surface agent, causes the oil to roll up into droplets. They are lifted and rinsed away. Surfactant. The surfactant active agent has a water-loving, oil-loving part. Surfactants. And what is the role of water? It's a universal solvent, neutral, hard water, minerals, soft water preferred. Allows lather. Hard water is hard to lather. And it's harsh on the hair too. It dries it out. Okay, so let's go. We're going to review back over these different types of shampoos. So the first one is a plain shampoo. Usually strong, high alkaline, not for chemically treated hair. Followed with an acid rinse. Soapless shampoo is able to lather without harsh alkaline ingredient. It works in soft and hard water. Soapless shampoo. Acid balanced shampoo. It's made to have the same pH as the skin and hair. Will not strip color. So that's great to note for all of the color specialists, up and coming color specialists. So acid balanced shampoo is made to have the same pH as the skin and hair and will not strip your color, the color. Medicated, often must have prescription, designed to treat scalp and hair problems. Now I know when my clients used to come into the salon and they had scalp conditions, they would come in with their prescription, but it had to have the prescription on the bottle. Okay, because a lot of times people want to come in with homemade, made up stuff and bring it to the salon. But as long as it had the prescription on it, I would use it on my client and with the directions, because with the prescriptions, they have directions, right? Clarifying shampoo. It's higher alkalinity. It has a higher alkalinity in order to remove residue such as product buildup. So you're going to hear that word a lot, clarifying. Sometimes if the client comes in and they have a lot of hairspray buildup on their hair or just product in their hair in general, we can shampoo their hair lightly with a clarifying shampoo before we go on with the perm service. Okay. So you would do that first and towel dry the hair and then continue with your 9 block like that, just getting that hairspray buildup on. And you'll be able to feel the hair when it has some kind of buildup on it. Okay. With the more you do hair and the more you experience working on clients, you'll be able to tell. It's just a cosmetology thing. Anybody else that would not understand what you're talking about. Okay. Anti-Dandruff. It controls the dandruff. You massage the scalp vigorously and rinse thoroughly. Okay. But with that one, I would try to do a scientific brushing first. This very light. Okay, because one thing about the scalp, it's hard to exfoliate that skin like you do the rest of your human body with the loofahs and the sponges and your washcloths. So with the scalp, it's hard to get in there and exfoliate unless you brush it. Okay, you don't want to really scratch the scalp. I know back in the day, that's what we would do before I went to beauty school. They would scratch the scalp, but you could irritate the scalp by scratching it with the comb. So we prefer to brush the scalp as in your scientific brushing methods. And then I follow up with an anti-dandruff shampoo. Because sometimes that dead skin is just sitting on the scalp and you don't want it to be there after you do the shampoo on the client. So you could brush it out, give it any debris that's in the hair, and exfoliate that scalp and get that dead skin off the scalp prior to you shampooing it. Okay. Liquid dry shampoo is used when client can't receive a normal shampoo. It works with wigs, it evaporates from the hair and is very drying. So the powder dry shampoo is for bedridden clients. And you can do the liquid one too. This is for clients that can't get into the salon or they in the hospital or in a care home. Okay. The Orris root powder absorbs soil and oil as the product is brushed through the hair. Don't use prior to chemical service. So they don't recommend you use this powder dry before a color or a relaxer or a virgin bleach or any chemical you put on the hair. Do not use the powder dry shampoo first. Conditioning shampoos contain animal, vegetable, or mineral additives that enter the cortex or coat the cuticle. Improve strength and porosity. Color shampoo. It contains temporary color molecules that stick to the outer cuticle of the hair. You notice it didn't say it's going to penetrate into the hair shaft or the cuticle, right? It's only going to coat the top of the hair. For thinning hair, it's a gentle shampoo. It's a lighter molecule weight, provide healthy environment for hair growth. And your all-purpose shampoo, it's low in alkaline, low surface agent, active agents, mild, does not strip the color, can be antifungal or antibacterial. So any questions about these 12 different kind of shampoos? Does anybody use a special shampoo when they shampoo in their hair?
I use a
use-
mask.
Oh, go ahead. Sorry.
What'd you
It's
say?
okay. I use a clarifying mask, like a hair mask, instead of a shampoo.
Oh, so would that be considered like the non-lather conditioning shampoo?
I don't know.
Does it lather?
No, it doesn't.
Okay, because usually those masks or the conditioning shampoos, they don't lather. So that's why I was just curious. Okay. When you said mask, that's usually a conditioner, right?
It's not a conditioner though. It's to like clarify my hair. It's like a mask for my hair.
Oh, okay, that's interesting because you know they have the mask conditioning mask. I never heard that. If you don't mind, when you come to class, can you bring it so I can read it? I love reading product labels.
Okay.
Be curious to see how that works.
Okay.
There's so many different products coming out. I mean, on the market, and it's good to share, you know. that knowledge, okay, to pass it down. Yeah, because I'm not the type of person that think I know everything. That's a new one for me. I heard, like I said, I heard a conditioning mask, but not a shampoo mask. I'm very curious. Who am I speaking with? I can't tell who's talking.
That was Jamila.
Oh, okay, great. I'm gonna be looking for it. Thank you.
No
Now,
problem.
I use a moisturizer shampoo with my hair because my hair, well, it used to be really a lot of density and the natural curls. But as I mature, I don't like to use the word age, it's getting thinner and my density is getting light. So with that said, that my hair tends to dry out just a little bit. So the moisturizer shampoo helps with the follow-up with the conditioner, the treatment. That makes sense. Sometimes you can use a plain shampoo and it might strip your hair, but some people's hair is oily than others. So that's why all these different types of shampoo come into play, because it depends on after you do your consultation with your client. Okay, everybody needs is a little different. Some people might run oily, some people might run dry, some clients might run normal. And then that's when you would decide which shampoo is best for that client. But for color treated hair, I would definitely always use a color shampoo because you don't want to strip that color out. Okay, and if you notice, we have plenty on the school on the back bar. We have a lot of coloring shampoo back there because we do a lot of color. Okay, so rinses and conditioners. The appearance is the shine and the luster. Porosity is the amount of moisture. Tongue twister. Manageability is how easy the comb passes through. And elasticity is the ability for the hair to stretch and return to its natural shape without breaking. So the types of rinses. You have a vinegar and lemon. They are acid rinses. They remove the soap scum and counteract the alkalinity. Okay. And I can testify that if you have a client that comes in and has a lot of oil buildup on their hair, and you use a lemon rinse on them, it kind of just rinses it out, just like that. It almost like just strips all of that film and hairspray and oil just out the scalp. Okay, because these women want their hair bouncing and behaving. They don't want it way down and just downright flat. Okay. Cream. A cream rinse softens, add luster, and only slightly acidic. It's slightly acidic. Okay, we're still talking about rinses now. There's a medicated rinse that controls the dandruff and minor scalp conditions. Okay, so basically there's 3 types of rinses: vinegar, lemon, cream, and medicated. Then we're going to talk about these conditioners. There are so many. If you ever go to Cosmo or Sally's and just look at all the shampoos and conditioners, I always suggest to my students to go take a trip to the beauty supply store and start familiarizing yourself with the products on the shelves. So conditioners, you have an instant conditioner. It coats the hair shaft, restores moisture and oils. It does not penetrate into the cortex layer. It's not for fine or limp hair. So remember, the instant is just coats the hair shaft, but it will restore the moisture and oils, and it does not penetrate into the cortex. And they do not recommend it for fine limp hair. Normalizing conditioner contains vegetable protein. Acidic pH causes cuticle to close after a chemical service. Now, there's some manufacturers that will call the neutralizing shampoo after a relaxer a normalizing shampoo. So it's good to know all these different terminologies. Okay, because you'll pick up the bottle and say, I need a neutralizing shampoo. This is a normalizing shampoo. It's basically the same thing. Okay. Cuticle, it closes the cuticle after a chemical surface, normalizing. Bodybuilding shampoo, required for fine limp hair. Now, this is the one you want to use for fine limp hair. Deposits protein, can use prior to a chemical service. And moisturizing shampoo, conditioner, sorry. Moisturizer conditioner. Humectants bind and hold moisture in the hair. Avoid use for several days following a perm, may go limp. They do not recommend you use this after a permanent wave service, because it says the hair might go limp. Then you have a customized conditioner formulated to meet special needs, moisture, and bodybuilding. Now, sometimes I would mix up, when I was in the salon, I'll mix different conditioners together, okay, to form a better conditioner for whatever my client was going through. So I might put a little moisturizer conditioner in with a keratin conditioner and mix it together and then apply it to my client's head for a deep penetrating conditioner treatment. Okay, now we're going to talk about perms. We're going to talk about the permanent waves. Okay, perms. Hair is wrapped around a tool. What is the tool?
The rod.
Yes, the perm rod. Processing lotion is applied to break the disulfide bonds. So that's the purpose of the processing lotion or the waving lotion. Okay, to break the disulfide bonds. Hair softens to shape of the perm tool. Rinsing removes the lotion. Neutralizer reforms the disulfide bond to the new shape. Okay, so the waving lotion is going to break the disulfide bond and create a new shape around the color rod, perm rod that you choose. And once you rinse that out, and when you put the neutralizer on, it's going to form to the new shape or rod, the rod size that you're giving it. And that's going to also lock in the curl. That's what really makes it permanent. Okay. Alkaline. Processes without heat. pH is 8.0 to 9.5. Thioglycolate acid and ammonium hydroxide are the main ingredients. Then you have an acid wave. The main ingredient is glycerol monothioglycolate. Speed is sacrificed for a more controlled curl. Heat may be used. And neutralizers. The main ingredient is hydrogen peroxide, sodium borate, or sodium bromate. Those are the main ingredients in a neutralizer. Okay. So those cover the perms. Alkaline, acid wave, and the neutralizer. Relaxers. What's the main ingredient for relaxers? Sodium hydroxide. So with the relaxers, they reduce the curl in excessively curly or wavy hair by changing the molecular structure. Okay, so basically with the alkaline perms, you are making a whole new curl. Okay, the client comes in, her natural curl pattern is too tight, or she doesn't have a curl at all, it's completely bone straight, and she wants some texture in her hair, so you would recommend a permanent wave. Okay, so with the relaxer, the client is coming in with a curl. She's coming in with a tight curl, or a wavy curl, or a medium curl. She doesn't want any curl pattern in her hair at all. So that's when you would use the relaxer. So some people might just want it loosen up. We call that a texturizer. When they just want their natural curls to just be loosened. Okay, you're not making the bone straight. But most women that want to relax them want their hair straight. Okay, they want to be able to swim or exercise and don't have to worry about their hair poofing up and reverting back to its natural curl pattern. So that's why they get the relaxers. So you can sweat and exercise and do Zumba and go swimming. And when you come out, your hair will be straight. Okay, it won't revert back. But in about 6 to 8 weeks, it's time for a touch-up again. Okay, as the hair grows out. So it reduces the curl in excessively curly or wavy hair by changing the molecular structure. Sodium hydroxide is formulated with 2% to 3% sodium hydroxide in heavy cream base with a pH of 11.5 to 14. So that tells you how strong it is. First of all, if you could change your hair from naturally curly to wavy to straight, that just tells you the strength in that. Okay. So you cannot mix sodium hydroxide with thioglycolate. It is not compatible. Do not use one on top of the other. You will cause severe breakage in the client's head, and over time, every day, more and more of the hair will come out shedding. So what does that mean? That means if a lady comes in and she has a perm already and it's been 2-3 months and her hair is down to the middle of her back, you know it didn't grow all the way out in 2 months. So she still has a lot of permanent wave in it. You should not put a sodium hydroxide relaxer on top of that. Now in reverse, if the lady comes in and she has a sodium hydroxide relaxer, she just got it done 2 months ago, and now she changed her mind and she wants a curl reformation, okay, which has the same ingredients in it as your alkaline acid waves, the ammonium thioglycolate. It will not take over. You'll go through the whole shampooing, 9-block, roll her up, put the lotion on, the neutralizer, you take the rollers down and her hair is bone straight. It would not even take a curl. Okay, so that's why they say they do not recommend that you put one chemical on top of another, vice versa. Thioglycolate is formulated with 4% to 6% thioglycolate acid with 1% ammonium hydroxide. The pH is 8.5 to 9.5. Cream base usually added. Okay, so what's the main ingredient in the permanent waves? It's ammonium thioglycolate. Okay, so you'll be able to tell sodium hydroxide for ammonium thioglycolate. And the pH scale for 1, because the sodium hydroxide is always going to be on the high end, and the permanent wave or the ammonium thioglycolate is going to be on the lower end. 8.5. So that tells you how much more milder that chemical surface is compared to the other one. Curl reformation. It loosens the texture of overly curly hair. Hair is smooth with a thioglycolate based cream rinsed, curl booster applied. Hair is then wrapped around the perm tube, processed to desired shape, rinsed and neutralized. So even though the curl reformation and your acid wave perms has the same ingredient, ammonium thioglycolate, what separates these two from each other is the natural texture of the client's hair when they come in. So for the most part, when we use the curl reformation, we're using it on ethnic hair because you have to use a cream-based straightener to straighten that curl, wipe that whole curl, that whole natural curl pattern out, rinse it, and then you could do your 9-block pick, and that's the perm tool size will determine the new curl pattern that client wants. They don't like that natural curl pattern, can't stand it, it looks too frizzy, it's too tight. They want a bigger, more definite curl pattern. So that's why they're coming into the professional, and you have to straighten it first, rinse it out, pick a perm tool that's at least bigger than their natural curl pattern. You don't want to go to the same size curl pattern, okay, that they naturally have. So most of the time when women or men come in for a curl reformation, they want their curl to be a completely different size curl than their natural curl. Okay, so I just wanted to share that. We're still talking about chemistry of cosmetics. It's a lot to cover. So the next would be hair color. Okay, but we're gonna take a 10-minute break. Okay, it's 3:01. I'll see you back at 3:11, ladies. Okay? 3:11. My 10-minute break.
¿Quieres agua, bebé? Sí.
Okay. Ay, oh.
Goodness, tickle in my throat. All right. We back. So hair color. Non-oxidative, oxidative, lighteners, developers, vegetable, metallic, and compound dyes are all hair colors. Non-oxidative is temporary, non-reactive, direct dyes. They coat the surface. Certified colors last until they shampooed out. So temporary colors only last until your next shampoo. And they kind of watery too. Okay. I mean, when I say like water. Okay. Semi-permanent. They last through several shampoos. They have more staining power. They penetrate the cuticle layer and slightly alkaline in pH. Color you see in the bottle is the color deposited on the hair. Okay. I used to do a lot of semi-permanents in my salon when I worked in the salon. And they're good because you can use a lot of those on after the client gets a relaxer or a permanent wave. Okay. As long as you don't have to mix it with developer and it comes straight out the bottle, like they say, and what you see is what you get, it's safe to use on the other chemical services. Oxidative is long-lasting semi-permanent, demi-permanent, or oxidative without ammonia. Use low-volume peroxide to develop color molecules, can only add color, not subtract, lift, or lighten. I would not use these on another chemical surface because you have to use a low-volume peroxide. And low volume meaning a 5 or a 10. Okay. And you add the 5 or a 10 so it wouldn't bleed out. Like when people start sweating or exercise and their color's running out of it. And that might happen in a temporary color though. If you sweat profusely like that, it might start running. Just a warning. I'm talking about the temporary one. And permanent color. It's oxidative with ammonia. Colorless molecules combined with peroxide to build colored molecules that link together in the cuticle and cortex and become anchored, can lighten and deposit. Aniline derivative, most frequently used. So you have to perform a patch test 24 hours prior to the application of the aniline derivative color. Why is that? Because most people will be allergic to the aniline derivative. Okay, not necessarily the color, it's the aniline derivative that's in the color. So you want to take a PD test, which is what? Predisposition test for allergies, okay? Oxidants, ability to release oxygen needed for chemical change. So that's why once you mix your developer with your color and it starts oxidating the air, the oxygen gets to it, it's going to start activating it. Okay. Hair lighteners, bleaching or decoloring, colorizing oxidation of natural melanin in the hair. Ammonia, common ingredient, is alkaline. So you have two types of hair lighteners. You have on the scalp and off the scalp. So on the scalp is gentle enough to be applied to the scalp. Makes sense, right? The answer's in there. If you could put a lightener or bleach on the scalp, you know it's a much milder. So the oil is oil and mild, and the pH is a 9. pH is a 9. The cream is most popular, prevents dripping. Used for full head lightening. Okay. And it's off the scalp. It's powdered bleaches, stronger than on the scalp. It lightens faster, and the pH is about 10.3. Tells you how strong it is, 10.3. And it's used for highlighting and weaving. When on the scalp, you can use that for your virgin bleach or your virgin bleach retouches. That's when you will use the on the scalp. Okay, because you got to get close on that base. Developers. Hydrogen peroxide is most common. 20 volume is used most often. pH is 2.5 to 4.5. Permanent colors require peroxide to develop their color molecules. Shelf life, usually 3 years. So your developers, where you get your 10, 20, 30, 40, or you have it back there in your lab at the salon you're working in, you need to put the date on it at the bottom of the bottle so you'll know. But most of you cosmetologists that graduate from North Adrian's Beauty College, you're going to be moving so fast and have so much clientele that you're not going to be able to have your peroxide sitting there longer than three years. You're going to be moving that product so fast. Them clients going to be lined up for you. You ain't going to have time for your product to sit for 3 years. Okay? I'm already knowing. We ain't even get there yet. Hydrometer is used to measure strength of hydrogen peroxide. It's good to have if you use a lot of developer. The shelf life is 3 years for hydrogen peroxide. So vegetable, metallic, and compound dyes. Repeated use coats and builds up on the hair shaft, causing damage to the hair. More of these colors are used. More color change takes place. Henna will give you reddish highlights, and metallic will fade to unnatural shades, look and feel dry. Then there's a lot of women that'll go get their henna because it's almost like, it almost looks and smells like dirt. And they will just mix it with water and stir it up and put it on their hair. And most people that I ran across that had henna in their hair, it does have that reddish tint of reddish highlights in it. And of course, you can see it more on women who have gray in their hair. Okay. Okay. So let me call on, describe each of these in your own way. What are the 2 types of perms? Don't everybody, this is question and answer time. Don't everybody speak at once. What are the 2 types of perms?
Sodium hydrate, and
Okay, so we're looking at acid.
The alkaline and the acid wave.
Yes, we're looking for acid and alkaline. Now, what is the pH on the acid? Because that is for heat, milder, and it needs more tension. Needs tension.
6.9 to 7.2.
Very good. And the alkaline, do you use heat with that?
No.
Nope. It's considered a cold wave. No heat. What is the pH on that?
8 to 9.5.
8.0 to 9.5, exactly. Okay, so the second one you was talking, I don't know, was that Jay, when you said the sodium hydroxide?
Wait, what?
Did you answer the sodium hydroxide? Was that you?
I don't think so.
Okay, somebody did. Okay, so the lasting effects caused by sodium hydroxide and why it must be handled with professional care. So sodium hydroxide will be your next chemical, right? It's not called a perm, it's called a relaxer. If the effect on the hair is irreversible. So once you put it on, some women will come into the shop and say, I did it, but I did it 6 weeks ago, but it's still in the hair. Because the average head of hair only grows a ½ inch a month. That takes 2 months to get an inch. Oh my goodness, that fur baby. So it takes a minute, it takes a while, it takes a couple of years for your hair to grow, never mind a chemical to grow out of it. Okay, so they'll say, I only had it on for 5 minutes. I didn't leave it on that long, but once it touches that hair shaft, it's in there. You have to wait for it to grow out. So it says, once the bonds have been broken with the sodium hydroxide relaxers, it cannot be reformed. The hair must grow out. Okay, let me repeat that. Sodium hydroxide's effect on the hair is irreversible. Once the bonds have been broken by the sodium hydroxide, it cannot be reformed. The hair must grow out. And oxidants develop the chemical change by releasing what? Oxidants develop the chemical change by releasing what? Okay, ladies, you're gonna be testing on this next week. You know, this is the time to have questions and answers. We can go over it. Oxidants develop the chemical change by releasing oxygen. By releasing oxygen. Okay. What are the 5 elements found in the hair? What are the 5 elements found in the hair?
And oxygen, hydrogen, nitrogen,
And the S.
sulfur.
Yes.
I was just trying to
Carbon.
catch up with my brain. I'm like, did I say them all?
Yeah, you're doing good. Carbon, oxygen, hydrogen, nitrogen, and sulfur. Cohen's. You could abbreviate it like Cohen's, whatever it takes to remember it on the test. C-O-H-N-S, Cohen's. Why is the pH scale important to a salon professional? Why is the pH scale important for the salon professional?
Different products are going to affect the chemistry or the pH levels of the skin and the hair, and we need to know how to bring that back.
Yes. And
You don't want
and it indicates,
to,
it
You don't wanna-
indicates whether a substance is acidic, neutral, or alkaline. Remember, acidic on the left side, neutral in the middle, and alkaline on the right. Okay. When the guides and knowing the effects various substances have on the hair, skin, and nails. So what you said combined together. So it's going to affect the hair, skin, and nails. But it's good to know, not only for your color, for your other chemical services. Okay. So what if the client says, I had a perm before and my hair was so sensitive and I burn easily? Okay, that's probably your opportunity to say, well, let me use a mild perm. Maybe they use the regular or a resistant. Okay, because there are different strengths in all these chemicals, right? Okay, so it's definitely, you're never gonna not ever use the pH scale. That's for sure. Compare the function of a hydrophilic molecule to a lipophilic molecule. A hydrophilic molecule is attracted to water, and a lymphatic molecule is attracted to oil. Okay, we haven't went over that one, but you could write it down now. So the functions of the hydrophilic molecule to a lymphophilic molecule. So one attracts water, the hydrophilic, hydrophilic, HYDROPHILIC molecule is attracted to water, and the lipophilic, LIPOPHILIC is attracted to oil.
I don't even see that in our smart notes as something that we should have written down.
It's under the, it is in the smart notes, it's under the knowledge grid. You know how you start challenging yourself and learning challenge? It's under a heading called knowledge grid. I have an old book too, so I don't hope that that's not it. Did you write down the two main things? You can always look it up later.
Yeah, I wrote them
Just for
down.
FY, okay. All right. Clarify the responsibility of ammonium hydroxide within an alkaline wave. Okay. So your ammonium hydroxide found in an alkaline waves is responsible for causing the hair to swell, making it easier for the thioglycolate acid to penetrate the hair structure and break the disulfide bonds. So you know how we always say stay within that margin on your perm rod? Do not have the hair overlapping on the perm rod because the hair will swell once you put the solution on it. So your textbooks is saying that the ammonium hydroxide that's found in the alkaline wave, that is what is responsible for causing the hair to swell on that rod, making it easier for the thioglycolate acid to penetrate into the hair structure and break the disulfide bonds. It also helps to shorten the processing time. Okay, so this one chemical ingredient will not only make the hair swell, it will speed up the processing time. So that's why the client most likely will sit there for 10 minutes instead of 35 and 40, because you know they will overprocess it then. Okay. We normally don't go no higher than 20 when we process a permanent wave. I mean, that's in extreme cases. And that's why you have to read those chemical record cards. Because most of the clients that come in and are getting their hair permed for years, okay? And they know their hair could usually take it if they have to sit just a tad bit longer. Okay, so differentiate between the process involved with chemically relaxing the hair with either a sodium hydroxide relaxer or a thioglycolate relaxer. Okay, so two of them are two completely different chemicals that will give you the same ending results. So right now I'm going over the sodium hydroxide relaxer and the thioglycolate relaxer, okay? The process of a thioglycolate relaxer involves breaking the disulfide bond between two sulfur atoms. Once again, the process of a thioglycolate relaxer involves breaking the disulfide bond between two sulfur atoms. So what's a thioglycolate relaxer? That would be your oh my God, your Japanese perm and what was that popular one they took off the market? Brazilian Blowout. It's similar to that. Okay. You have to put heat on the hair. Actually, it goes on blow dried hair, dry hair. It's a process. That's why they charge about $500 a pop for that in the salon. Okay, because it's a few steps that involves that. Okay, so the process involved with a sodium hydroxide relaxer involves breaking the disulfide bonds between the first sulfur atom and the adjacent carbon atom, making it irreversible.
You say that again?
The process involved with a sodium hydroxide relaxer, which is the lye relaxer, the main ingredient, involves breaking the disulfide bonds between the first sulfur atom and the adjacent carbon atom, making it irreversible. So by having those two bonds together, the sulfur atom and the adjacent carbon atom, that's what makes that chemical reversible. You can't switch to another chemical. But with this thioglycolate relaxer, the main ingredient is that ammonium thioglycolate. So say if the client had the hair straight and they didn't like it, you know, after a month, it's like, I'm tired. Still got to bump my hair with the flat iron or, you know, air form it. I don't want to do that. I want to get a permanent wave. You can take that client back and roll them up and do a non-block one because it's the same base ingredient. You can't switch in between the sodium hydroxide and ammonium thioglycolate, but you can't go from ammonium the thioglycolate relaxer, which is straight, right, back to rolling it up on a non-block. All right.
And the plate was breaking the disulfide bond between two sulfur atoms?
That's the thioglycolate? Is that what your
Yeah.
question? Okay, it's breaking the disulfide bond between two sulfur atoms.
Okay.
Mhm. The process involved with okay, I'm going on to something else. So that's the answer. The process of a thioglycolate relaxer involves breaking the sulfide bond, yes, between two sulfur atoms. Mhm. Define how oxidative colors are able to cause a chemical change in the hair. Okay, oxidative colors are able to cause a chemical change in the hair because they are mixed with an oxidant that has the ability to release oxygen to fuel the chemical process. And what is the oxidant?
Hydrogen peroxide.
Exactly. So when you mix those two together, that's what causes the chemical change in the hair. Okay. Because if you use a temporary or a semi-permanent, it's going to be what you see is what you get straight out the bottle. No
So that one's
chemical.
just because they're mixed with an oxidant to create the chemical change?
Yep. Exactly. Because remember, you got the non-oxidative colors, which is your temporary and your semi-permanent, and you have your oxidative colors. Okay. All right, so I have some let's see. Some multiple choice. The scientific study of matter and the physical changes in matter is called what? Is it called chemistry, physics, anatomy, or psychology? Come on, I got about, how many students here? 1, 2, 3. 18. Somebody else jump in. You should have your notes and your writing tablets in front of you.
Chemistry?
Huh?
I said chemistry.
Yes, chemistry. So the scientific study of matter and the physical changes in matter is called chemistry, correct? How many different forms of matter are there?
3.
3, exactly. There are 3 different forms of matter. Matter with definite weight, volume, and shape, such as your leather shoes, is what form of matter?
Solids.
Yep, solid. Very good. Melting an ice cube could be an example of what? Is it a chemical change, physical change, chemical reaction, or organic change? Melting and
Physical.
physical, correct. A change in a substance that creates a new substance with properties or characteristics different from the original substance is what? Chemical, physical, elemental, or anatomical?
Chemical.
Yep, it's a chemical. Very good, because the ice cube is the same substance, right? It's just melting. So that's physical. But the chemical change is correct because now you change it from one substance to another. What form of matter is hair? What form of matter is hair? Is it solid, liquid, inorganic, or gas? It's hair. Hair
Solid.
is a solid matter. Yes. Which of the following activities is not an example of a physical change? Is it rusting of a nail? Is it shattering a piece of glass? Is it performing a haircut, or is it performing a thermal style? Which one is activities is not an example of a physical change? It's rusting of a nail. That is not an example of a physical change. So shattering of a piece of glass, performing a haircut, or a thermal style are all examples of physical change. The only one that's not is rusting of a nail. Everything that is alive or was once alive contains what? Is it oxygen, hydrogen, nitrogen, or carbon? Everything that is alive or was once alive contains carbon. The study of minerals would involve what? Is it organic chemistry, inorganic chemistry, living matter, or chemical bonds? The study of minerals. The study of minerals would involve inorganic chemistry. What is the smallest complete unit of an element?
Atom.
Yep, it's an atom. Within an atom, protons and neutrons are found in the, is it orbit, shell, nucleus, or protoplasm?
Nucleus.
Yeah, very good. Because that's the right in the middle, that nucleus, right there. The atomic number of an atom indicates the number of what in the nucleus? The atomic number of an atom indicates the number of what in the nucleus? Is it electrons, protons plus neutrons, neutrons plus electrons, or just protons? It's protons. So the atomic number of an atom indicates the number of what in the nucleus is the protons. The shell of an atom consists of, is it neutrons, protons, electrons, or protons and neutrons? The shell of an atom. The shell of an atom consists of electrons. Electrons. The molecule formed when different elements are joined together chemically is called what? Mixture, compound, solid, or liquid. The molecule formed when different elements are joined together chemically is called a compound. Compound. Carbon, nitrogen, oxygen, and hydrogen are the building blocks of, is it amino acids, elements, mixtures, or end bonds? Carbon, nitrogen, oxygen, and hydrogen are the building blocks of amino acids. Amino acids. Amino acids join together in chains to become compounds, elements, chemicals, or proteins.
Proteins.
Yep, very good. Amino acids join together in chains to become proteins. Hair is an example of what? Is it an element, form of protein, mixture, or solution? Hair is an example of a form of protein. A form of protein. Hair is primarily composed of, is it keratin, trace minerals, protons, or electrons?
Keratin.
Yes, keratin. Hair is primarily composed of keratin. The backbone of all protein molecules is it the side bond, hydrogen bond, peptide bond, or amino acid? The backbone of all protein molecules is the peptide bond. What type of, talk so fast. What type bonds are individually very weak? Individually very weak. Is it the hydrogen bonds, the side bonds, the sulfide bonds, and peptide bonds? It's the hydrogen bonds. What type of bonds are individually very weak? Are the hydrogen bonds. The most important side bond a salon professional is concerned with is it the hydrogen bond, the van der Waals forces, salt bonds, or the sulfide bonds? Which one is the most important for a salon professional?
Disulfide.
Yep, the sulfide bonds. Very good. An example of a chemical change is it shampooing hair? Is it styling the hair on rollers? Is it perming, or is it using a blow dryer? An example of a, perming is an example, very good, of a chemical change. The pH measurement scale indicates whether a substance is it a liquid, solid, or gas, or organic or inorganic, or hard or soft, or acid, neutral, or alkaline? The pH scale measurement indicates whether a substance is acid, neutral, or alkaline. Okay. So remember, when you look at it, acid, neutral, or alkaline. Okay. Okay, let's see. Substances of acidic or alkaline nature dissolved in water or contain substances of acidic or alkaline nature dissolved in water and or contain, is it water, hydrogen, carbon, or salt? The answer is water. That's why I had to look at it twice. Substances of acidic or alkaline nature dissolves in water and or contain water. A substance with a pH of 6 would be what? Is it neutral, acidic, alkaline, or salty?
Acidic.
Yes, very good. A pH of 5 is how many more times acidic than a pH of 6? A pH of 5 is how many more times acidic than a pH of 6? Is it 1.5, 10, 100, or 1,000? It's 10. But remember, we talked about that 1,000, 10,000, 100,000 on the scale. Wait 1 second. So remember, the logarithm, each number increases by multiples of 10. I don't know if you can see that right there. So that's why 6 would be 10 times more than 5. Because 8 is 10 times, 9 is 100 times, 10 is 1,000 times. Okay. Where did we leave off at? The pH of skin, hair, and scalp is in which of the following ranges? Is it 4.5 to 5.5? Is it 6.5 to 7.5? Is it 8.5 to 10.5? Or is it 11.0 to 12.0? The pH of skin, hair, and scalp. What range would that fall under?
4.5 to 5.5.
Say that again.
Where were the options again?
It's 4.5 to 5.5, 6.5 to 7.5, 8.5 to 10.5, or 11.0 to 12.
4.5 to 5.5.
Exactly, you are correct. So the pH of skin, hair, and scalp ranges from 4.5 to 5.5. Okay, so all of the following statements regarding pH are true except, so I'm looking for the one that's not true. Is it pH measurement scale ranges from 0 to 14? Is it a solution is acidic if it has more negative hydrogen ions? Is it solutions with equal hydrogen and hydroxide ions are neutral? Or is it pH is a unit of measurement that indicates whether a substance is acidic, neutral, or alkaline? So the answer is, out of all 4, is a solution is acidic if it has more negative hydroxide ions. So that one is not true. The other choices that are true were pH measurement scale ranges from 0 to 14. We know that if we look at the scale, right? Solutions with equal hydrogen and hydroxide ions are neutral. That's another true statement. And the last one is pH is a unit of measurement that indicates whether a substance is acidic, neutral, or alkaline. Distilled water with a pH of 7 is what? Is it salt, alkali, acid, or neutral? pH of 7.
Neutral.
Yes, neutral. So we always say neutral on the pH scale is 7. Most shampoos and conditioners are acid balanced to what range on the pH scale? Most shampoos and conditioners are acid balanced to what range on the pH scale? Is it 2.5 to 3.5? Is it 4.5 to 5.5? Or 6.5 to 7.5? Or 7?
4.5
Mo-
to 5.5.
Exactly, you're correct. Most shampoos and conditioners are acid balanced to what range on the pH scale? And the answer is 4.5 to 5.5. Most shampoos and conditioners. It doesn't say all, most. Okay. What defines cosmetics as articles intended to be rubbed, poured, sprinkled, or otherwise applied to the human body or any part thereof for cleaning, for cleansing, beautifying, promoting, attractiveness, or altering the appearance? That's a long question. Let me repeat it. What defines cosmetics as articles intended to be rubbed, poured, sprinkled, or otherwise applied to the human body or any part thereof for cleansing, beautifying, promoting, attractiveness, or altering appearance? Is it A, the Food and Drug Act of 1938? Is it B, OSHA, OSHA? Is it C, the EPA, or is it D, the USDA?
The Food and Drug Act of 1938.
Very good. The Food and Drug Act of 1938 is what defines cosmetics as articles intended to be rubbed, poured, sprinkled, or otherwise applied to the human body or any part thereof for cleansing, beautifying, promoting, attractiveness, or altering the appearance. Food and Drug Administration. How many general classifications are assigned to categorize cosmetics used in the cosmetology industry? How many general classifications? Is it 3, 4, 5, or 6?
6.
You are exactly right, 6. So there are 6 general classifications that are assigned to categorize cosmetics used in the cosmetology industry. Absolutely correct. A mixture of 2 or more kinds of molecules evenly dispersed would be, is it A, solutions, B, suspension, C, emulsions, or D, ointment?
Solution.
Say that again, I'm sorry.
Solutions.
Yes, very good. So a mixture of 2 or more kinds of molecules evenly dispersed would be solutions. Water is considered to be a universal solvent because it is A, not compatible of dissolving more substances than any other solvent. Is it B, capable of dissolving more substances than any other solvent? Didn't I just say that? Oh, not capable. And B is it capable? C is a dilute solution, or D is a concentrated solution? Water is considered to be a universal solvent because
B.
it is, yep, B, capable of dissolving more substances than any other solvent. Okay. What substance is formed when 2 or more non-mixable substances are united with the help of a binder? Is it solutions, powders, ointments, or emulsions?
Emulsions.
Very good. So a substance that's formed when two or more non-mixable substances are united with the help of a binder is emulsions. Mixtures of organic substances and a medicinal agent are what? Is it solutions, emulsions, ointments, or suspensions?
Ointment.
I believe you're correct. That's my spot. Yep. Mixtures of organic substances and medicinal agents are ointments. Which type of hair usually needs to be shampooed more often? Is it oily, dry, normal, or blonde? Why did they put that? I'm just reading from the book. Which one has to be shampooed more often?
Oily.
Oh, yes, correct. Just think about it, right? Oily. Because dry hair, oh my God, can you imagine the shampooing it often? This will dry it out even more. And I don't know why they put blonde in there. That is not my right. A surfactant is used to, is it change the color of hair, condition the hair, add oil to the hair, or remove oil from the hair? Surfactant, we went over that.
Remove oil from the hair.
Yes, remove oil from the hair. Yep. Another name for the oil-loving part of a surfactant is what? Oh my goodness, lipophilic. I'll just give you that one, lipophilic. Another name for the oil-loving part of a surfactant is lipophilic. Which of the following statements about surfactants is not true? Not true. Is it contains a lipophilic part? Is it used to remove oil from the hair? Does it contain hydrophilic part, or does it prevent shampoo from lathering? Which one does not belong? It prevents the shampoo from lathering. That is not, it's not true. What type of shampoo contains low alkaline content and a low concentration of surface acting agents and generally does not correct any special condition? What type of shampoo? Is it plain, all purpose, clarifying, or medicated?
All purpose.
Very good, correct. Which of the following shampoos would not be used for chemically treated or damaged hair? Is it plain, non-stripping, all purpose, or acid balance?
That one's plain.
Yep, correct.
Forest-root.
Shampoos that often have a higher alkalinity in order to be able to remove residues such as a product buildup or dirt are, is it clarifying, powder dry, thinning hair, or conditioning?
That one's clarifying.
Yes, correct, clarifying. Clarifying shampoos often have a higher alkalinity in order to be able to remove residues such as a product buildup or dirt. Is a clarifying shampoo. A shampoo that contains orris root powder to absorb soil and oil is classified as what? Is it color shampoo, powder dry shampoo, anti-dandruff shampoo, or liquid dry shampoo?
Powder.
Orris root, huh?
The powder dry.
Yep, powder dry contains orris root powder to absorb soil and oil. The ability of the hair to stretch and then return to its natural shape without breaking is referred to as, is it porosity, elasticity, manageability, or luster?
Elasticity.
Elasticity is the ability of the hair to stretch and return back to its natural shape without breaking. That is correct. Acid rinses help what? Do they open the cuticle, close the cuticle, add softness, or control dandruff? Acid rinses.
Close the cuticle to keep it compact.
Just say that again. I'm sorry.
Close the cuticle. to
Yep,
keep it
close the
compact.
cuticle.
Yeah.
Acid rinses help close the cuticle. What type of conditioners contain hydrolyzed animal proteins and are recommended for dry, brittle hair that has been chemically or mechanically or chemically damaged? Moisturizer. Moisturizing conditioners contain hydrolyzed animal proteins and are recommended for dry, brittle hair that has been mechanically or chemically damaged. Okay, and we'll do one more, and it's time to go. What type of conditioners coat the hair shaft and restore moisture and oils, but do not penetrate into the cortex or replace keratin in the shaft?
Instant.
Is it? Yep, good, instant. Okay, ladies, so that ends our Zoom for today, and I will see you back tomorrow at 2 o'clock, 2 to 4. Okay,
Okay.
any questions? Okay, we'll go back over tomorrow.
Bye.
Bye,
Bye.
bye,
Bye, Miss Michelle. Thank you.
bye. You're welcome. Thank you.